1, we learned about models, and topic 1.1 was models and units, started in on units and developing mathematical models and linear equations. In 1.2, we're going to be talking about measured quantities. So we measure things all the time. How wide a doorway is, for example, we only need a ruler to answer that question. Okay? But if we need to know, say, the density of a block of wood, we would need to have more. We would need the ruler. We can get at the volume, because density is mass over volume. We would need the ruler to be able to measure multiple sides of the block. We would also need a scale or a balance to measure the mass of the block. So in this case, the length of the doorway is a sort of fundamental property of length. We call that a fundamental property, whereas the density involves multiple fundamental property quantities put together, and we call that a derived quantity because it contains length multiplied together and also mass. Okay, so fundamental are the most basic. And not properties, we'll use quantities. Sorry. Most basic things to measure. And we'll need 3 types of these. Length, time, and mass. And for we also we'll use our fundamental quantities together to come up with derived quantities, like density, like volume. A derived quantity is formed from combinations of fundamental quantities. Okay? And how derived quantities are formed, and looking at that or analyzing derived quantities is called dimensional analysis. Because it gets at the fundamental, formula and the fundamental quantities that formed the derived quantity. So, for example, let's do a dimensional analysis of area. Now, to get an area, we might have a formula or the units of area are meters squared. Okay? And we can think of that as like squares be side squared, or a rectangle would be length times width. And that would be, so area has a length times a length. Okay? And we can see that in its units of meters squared. How about density? Well, density may have the units of kilograms over meters cubed. So in this case, we would have mass divided by volume, which is actually length times length times length. Speed is another one. Miles per hour, but or also something like meters per second. Meters is the length over the fundamental quantity of time. To let you understand more about the thing that you are measuring. Okay, so 1.2a here are our standard units. Okay, and what are our standard units for our three fundamental quantities? So these, in physics, we use ones that are sort of close to human experience, we'll say. Whereas in chemistry, they use standard units that are different because they're talking more about atoms and things like that, so they have different ones there in chemical experiments. But for us, our standard units for fundamental quantity length, the standard unit that it's recorded in is meter. Okay. For time, standard unit is the second. And for mass, the standard unit is kilogram. So let's get used to these a little bit. Let's look at for a ninth grader. For an average ninth grader. For example, what is the height of an average ninth grader? Now, we're all a mixed match, obviously, but let's just say that the average was 5.5 feet. 5 feet 6 inches. Okay? So 5.5 feet. That's 5.5 feet. And we want to change that to our standard unit. Well, height is a length, so we would want to go to meters. Well, I can look it up, and I can see that 1 foot equals 0.3048 meters. So to take 5.5 feet and get it to meters, I would have to multiply by 0.3048. If we're going to see how to, when we get to unit conversions in a minute, a little easier or a better way to do that. But 5.5 times 0.3048, that would give me 1.68 meters. So the average ninth grader is 5.5 feet, is 1.68 meters. Okay. How about the average age of a ninth grader? Well, let's just say, obviously it changes as the year goes along, but let's say about 14 and a half years old, right? Well, let's see. I know that there's 365 days in a year. I'm trying to get the seconds. I know that there's 24 hours in a day. I know that um, there's 60 minutes in an hour and 60 seconds in a minute. If we multiply all those together, we could see that we have 457, 272,000 seconds is the average age for a ninth grader. How about the average math of a ninth grader? Well, we could say the average ninth grader has a mass or a weight of, let's say, I don't know, let's just say 110 pounds. That might be a little high, I don't know. Okay. Now, I know that for on Earth, 2.2 pounds and 1 kilogram. So if we divide this by 2.2, we could see that the average is, oh, that worked out well, 50 kilograms is the average mass. So there we go. Now, 1.2b is unit conversions. We have to be able to go from unit to unit. How do I take something and get to standard units? I just took your age and your mass and your height and changed those to standard units, and I did it sort of a sloppy way. I want to show you a way to do it more uniformly so you can do it for any type of units. So much of our experience, of course, is with things other than standard units. The standard units for speed is meters per second. But most of the time we see things in miles per hour, right? On street signs, or kilometers per hour. How can we go from miles per hour or kilometers per hour to meters per second in a uniform way? So there's three concepts to consider. And in these three concepts, the first one is that 2.54 does not equal 1. Is that clear? However, we can say this, 2.54 centimeters does equal 1 inch. That's true. 1 inch is 2.54 centimeters. So, therefore, if 2 equals 2, another therefore, 2 over 2 equals 1, right? Therefore, 2.54 centimeters over 1 inch equals 1. Or 1 inch over 2.54 centimeters equals 1. And these fancy versions of 1 are our unit conversions. Okay? And 3, 5 sheep times 1 equals 5 sheep. And 5 sheep times 1 times 1 times 1 still equals 5 sheep. In other words, we can multiply by as many unit conversion that we want, these things, fancy versions of 1, as many times as we want, we'll end up with the same amount, the same quantity. We're just multiplying by 1 creatively. Okay. Of course, the best way to do this is to look at an example. For example, let's take 30 minutes and convert it to standard units. 30 minutes, what are the standard units for time? Seconds, right? And 30 minutes times 1, we know, is equal to 30 minutes. Okay? I also know, though, what is this fancy version of 1 that I want? Well, what I want is in 1 minute, I know how many seconds there are because I want to go to seconds. Right? There's 60 seconds in 1 minute. I put the minute on the bottom, and this is just a fancy version of 1, this thing right here. So the minutes cancel, and I have 30 times 60, or 1,800 seconds. 30 minutes is the same thing as 1,800 seconds. I only multiplied by fancy versions of 1. Now, one way that sometimes happens is you do it incorrectly. Say, I reversed it the wrong way. So this would be an oops, where I had 1 minute is 60 seconds. It's backwards. So it's still by 1. This is still by 1, but it doesn't make any sense when I do it that way because I get 30 minutes squared over 60 seconds. So I'd have 0.5 minutes squared over seconds, but what's minutes squared over seconds? It doesn't make any sense. So that would be the incorrect way to do it. Let's try another one. So let's say for 4 years, but we'll do it more. We did the years, 14 and a half years. I just wrote them down, but let's change 4 years to standard units. Do it more with these fancy versions of 1. So we start out with 4 years, and my fancy version of 1, the first one will be year on the bottom, and I know there's 365 days. You'll be given the unit conversions that you need to 365 days in a year, 2.54 centimeters in an inch, things like that. So in 1 day, I know there's 24 hours. In 1 hour, I know there's 60 minutes. And in 1 minute, there's 60 seconds. So if I go through that, I get 4 times 365 times 24 times 60 times 60. So I get 126,144,000 seconds. In scientific notation, that would be 1.26144 times 10 to the 3678 seconds. Okay? Let's try a multiple unit one. Okay? Well, so how about 100 kilometers per hour? When they start to get big like this, the standard units, I like to use a sort of a plan. So I have to take my kilometers and I have to get to my meters. So that's going to be a one step because I know meters to kilometers. Hours is going to be multiple steps. I'm going to go to minutes and then I'm going to go to seconds. Okay? So each of these steps, 1 and then 2 for hours, there's going to be 3 steps. Each of those steps is a fancy version of 1. So I start with 100 kilometers per hour. We could use just H or HR, I guess it's fine right now. Then I'm going to first change kilometers to meters. Well, I know it would be given there's 1,000 meters in 1 kilometer. Okay? So in 1 kilometer, I have to put it on the bottom. And the reason I put it on the bottom is so that the kilometers will cancel with the top one, like that. And now I see, and this is sort of like 100 over 1. Sometimes that confuses people, but if you do that, you see the 1's on the bottom, the 100's on top. Now my next, so I just did this step right here, kilometers to meters. But now I need to do hours to minutes. So if I do that one, I can see hours is on the bottom, so hours has to be on the top here, and minutes goes there. Well, what is that? There's 60 minutes in 1 hour, you see? And that's allowing me to tell where I put the 1 and where I put the 60. Now I got to go minutes to seconds. To do that one, I put minutes on top because it's got to cancel here, you see? This has to cancel with that. Seconds on the bottom. 60 seconds in 1 minute. So I can see by multiplying it all out that I'm going to end up with meters and seconds, and that's my standard units. And on top, I'm going to have 100 times 1,000, and on the bottom, I'm going to have 160 times 60. And if I do that 100 times 1,000 divided by 60 times 60, I better enter it the 60 times 60 with parentheses in my calculator, it will do it wrong. 27.78 meters per second. So 100 kilometers per hour is 27.78 meters per second. And that ends 1.2.